So you have to excuse the crudity of the video. I'm outside my lab and I'm actually using a mobile camera, but I've got some new goodies here. Ryanteck, who've been selling some interesting Raspberry Pi and robotic and electronic goodies, have recently stopped trading, sadly, but they had a closing down sale, which was an absolute bonanza. So I picked up a whole bunch of goodies from their closing down sale. Let's have a look at what we've got. So in this bag of goodies, first a bunch of heat sinks for Raspberry Pi. So I've got 4 heat sinks, and certainly for the Raspberry Pi 3s where I'm doing camera and Wi-Fi, those will be handy. We've got an LCD display. It's a 20 character by 4 rows I2C LCD display. Okay, that's going to be pretty interesting. So we should be able to use that with Raspberry Pi, with a Node MCU, with an Arduino. I2C means I can use it with just about everything I've got, with potentially some analog output pins. I wonder what that chip there is. It's probably a controller of its own. But I mean, this is a nice big display. This here, that's an A to D, an I2C analog digital converter. So PCF8591. So that's probably, if that's the name of the module, that's probably the name of the device on top. So you've got I2C in one end and ADC in the other. And again, being another I2C device like the LED, I seem to be on a a run with I2C devices. I can connect it to the Arduino, the Node MCU, the ESP8266, and the Raspberry Pi, and just about any other device I can think of. So that part number is the PCF8591T. You can actually see on the breakout board here, we've got a potentiometer, an LDR, so light dependent resistor, a thermistor, and the other bit is LED. We've got a set of jumpers here. Presumably it may be to actually configure that whether these analog inputs coming from these devices or straight other devices. So up here we've got a set of pins, analog 0, the I2C, ground and VCC. We've got a data sheet here. The PCF8591 8-bit A to D and D to A converter. So single chip, single supply, low power 8-bit CMOS data acquisition. Okay, 4 analog input, 1 analog output. That must be A0, whereas these are AN. So A0 is an analog output. That's an interesting little block diagram. There's your analog output. There's your analog inputs through a sample and hold. Now this should be interesting to play with. I mean, I suspect for the most part there'll be libraries to handle this on all the major devices. I think I'm wrong. That might not be for selecting analog inputs. That might also be for addressing on the I2C bus. Although I believe the data sheet said there were 3 selectable lines, and that's 4. So not sure how we set the address on the I2C bus. These here look like they are selecting the analog inputs, so if you follow the traces from them, they go up to all of those analog devices up there. So the I2C address of this must be fixed. I wonder if playing with some of these resistors that maybe pull ups, pull downs could change that. So maybe I could desolder a couple of these and get a different address if I wanted one. So these 1, 2, 3 pins are for the I2C address, and this last one is voltage. So it looks like 2 of them are held high, 1 of them's not connected. Maybe that means it'll default low if they've got a pull down internally. Next up in this bag of goodies, we have a breadboard power supply, and I think that's a switch between 5 volts and 3 volts, so that'll be handy. And there's also an on and off switch. There's an indicator LED. Well, that's frustrating, trying to get that out of the bag. Because you've got the breadboardable pins underneath and you've got pins on the top, it's quite well wedged. And sadly, these have been mashed down, so I need a pair of pliers later to go and fix that up. It's the YW Robot Power MB V2. You've got various pins here for getting voltage out, as well as using the breadboard bits along the bottom. The jumpers here for setting the actual voltages. There's jumpers either side. Oh, because there's 2 sets. Okay, so if you look under here, you've got 2 sets for the voltage rails on a breadboard, so this must happily span a breadboard. The 2 regulators, one must be 5, one must be 3. Set of resistors here, which are just and capacitor to support the regulators. In fact, I think those are all capacitors. An LED and a resistor for an on thing. There's a diode here, perhaps for polarity protection. An actual switch. That is a Cheng brand capacitor. I don't really know if that's a good brand. So breadboard power, like that a lot. I'm back in my lab and I thought I'd dig further into this breadboard power supply. I've been after a power supply for a while. The Ryanteck sale prompted me to get round to getting one. Apparently the DC in can go between 6 volts and 12 volts. So let's try a supply. So I've got here a random Netgear supply, and that's what, 12 volts at 1 amp. Now there's a little bit of tension, and I kind of show it this angle or maybe this angle. So it's pulling the board together ever so slightly, so that's possibly not good. This USB will supply voltage to an external device. I could run some power supply in here and then run that off to supply something that needs USB voltage, although I've got many USB power supplies anyway. So what I'm going to try and do is plug this in to that 12 volt supply and use my multimeter to measure the 3 and 5 volt lines, or 3.3 and 5 volt lines, and see what we get. Oh, and you'll note that there's nowhere here on the DC in where it does print its voltage range, sadly, and it also doesn't really print its polarity. So yet again, if you're silk screening a board that has one of these power inputs, please do put the polarity and the voltage. I know that most people go with the same standard polarity, but some don't, so I'd rather it was printed there. And let's turn it on and hope nothing goes pop. Oh look, that LED is on. And so I've got this rail set to 5 volts, so let's turn on the multimeter, throw it into the voltage range. 20 volt range should be about right. And I've got a couple of leads flying off of here, so I can just probe that way, because I haven't really got anything that will plug into the breadboard directly. 5 volts, so we've got 4.9 volts, so 0.05 volts out. I think that's reasonable. I think I'll say that's an acceptable, acceptable difference. I can live with that. We'll have to see how it performs under load. Oh, that's interesting. It's drifting a bit. Is that just because of my maybe that's because I'm not holding it on very well. I need to get some croc clip leads. I've already used one set in Spiderbot on a, well, it's a temporary basis until the batteries go in. Okay, let's try the 3 volts. Let's turn it off. 3 volts. Turn it on again. 3.26, so 0.04 volts out. Again, tiny bit of error, but it's not enough to be too worried. I love that there's an actual switch here. There are a lot of designs that leave out the all-important switch. So that's going to come really in handy for lots of little projects, I think. And I've got 2 of them, just in case I need to leave one in a project. So there is one other thing that I'm a little bit less than pleased with, which is that it takes quite a lot of force to get that into a board with those 2 sets of pins. It means it's quite stable, so it's not dangling. But it's well, maybe the first time I plugged it in, it was a little bit stiff, and I think the pins had bent slightly in packaging or something, so they were all slightly flattened down. So I had to take a pair of pliers to straighten them all out. Anyway, that's the YW Robot Power MB V2. So next up, I bought a set of different chips. This is the MPC23017, so it's an I2C IO expander. A 16-bit IO expander with serial interface. Hold on, is that the same device? Ah, no, here you go. Here is the high-speed I2C. So, 16-bit remote directional IO port. IO pins default to inputs. High-speed I2C interface, 100 kHz, 400 kHz, 1.7 MHz. SPI as well. Okay, 3 hardware address pins, so we can change the address. And since I've got the bare chip, that's going to be easy to do. Configurable interrupt output pins, so active high, active low, open drain. We can operate independently or together. So this is an extremely versatile chip. So I guess I'll dig further into the datasheet in a later video, but this is also following the theme of using I2C and serial based devices to improve or expand the amount of IO I have. So sometimes I do find I need more pins, more to do more things with. So putting this alongside the A to D, and I can take any chip I like, keep my code on one chip, but have many other devices giving me more I/O. 74LVC 245AN. So that's an octal level converter. So that will do 8 channels of shifting voltage levels. So should be happy to go between 5 volt and 3 volts. So I can connect devices. Obviously, when you've got a controller at 3 volts, devices at 5, these should do the trick for me. And I've got 2 of these. These are a shift register, so that's the 74HC595. So again, this allows me to maybe use fewer I/O pins with a device, and these are all about saving I/O pins and interfacing. And finally, last but not at all least, 2 great big bags of assorted LEDs of all colours, including, look at these big fat coloured LEDs, and there's some square 1980s display style LEDs. There's just standard 5mm LEDs. Got greens, blues, reds, yellows. This is going to be great because I can maybe go and do stuff with the kids with these. So when we're experimenting with Raspberry Pis, having lots of stuff to light up, well, that'll make them really happy. So that'll add a little bit more pizzazz to some of my projects, having this many LEDs. I've got a cupboard with some old crusty red LEDs, but no, I really needed some fun ones. Now, what was great about it, I suppose, was this closing down sale meant some of this was horrendously cheap, and some of this was, more than 50 or 60% off. There was almost a rush on, as many electronics nerds and robotics guys got themselves to Ryanteck, and even their site fell down because there were so many people at the same time. I believe he's gone off to focus on course and other matters. I think he'll be missed in the community, but maybe he'll still be around. We'll see him at Raspberry Pi parties. But yeah, this little bag of goodies, this will be keeping me fun for a while. Well, I hope you've enjoyed seeing that little collection of items I've gotten from this rather neat setup, and I hope you'll be back to see what I build with them. If you liked it, give it a thumbs up. Check out my Patreon channel. It's patreon.com/OrionRobots. And go make stuff and be awesome. Bye!